Okay, so this is 5.3D, page 466, Gauss-Jordan elimination. So what we've got here is the answer from example number 1. This is what we came up with, and remember we rewrote this as 1x minus 2y minus 10z equals negative 6, 1y plus 8z equals 3, and then z equals negative 1/2, and then we did our back substitution there, and we're able to find x, y, and z. Okay, the difference between the Gauss-Jordan elimination and what we just did is we are going to not only make these all 1s and these zeros, but we're also going to make the negative 2, the 8, and the negative 10 zeros. So everything's zeros except the main diagonal. So really what we're going to do is we're just going to continue on. We're going to do the same thing, moving rows around, multiplying by negatives, dividing by their opposites, or dividing by their numbers and doing all that, so that this negative 2, negative 10, and 8 can be zeros as well. So this is where we left off. We were able to find the answer here, and we're just going to keep going. So what we're going to do here is we're going to, let's change this negative 10. I'm just going to follow along with what the book does. It doesn't really matter how you do it. We could change this negative 2 to a 0, but the book for some reason changes the negative 10 to a 0. So we look here at this third row because there's a 1 here, and if we multiplied that third row by 10 and add that third row to this row, that 10 times 1 here would be 10, plus negative 10 would make that a 0. So that's what we're going to do here. So we're going to make the middle row stay the same. So let's just do that. In fact, let's make the middle row and the bottom row the same because we don't have to change those, especially the bottom row. It's already set up. Alright, so let's multiply the bottom row times 10. 10 times 0 is 0, plus 1 gives me a 1. Okay? Alright, then we've got 10 times 0 is 0, plus negative 2 keeps that a negative 2. Then we've got 10 times 1 is 10, plus negative 10 is 0, and then we've got 10 times negative 1/2, which is negative 5, plus negative 6 is negative 11. So now let's worry about the second row. Let's get this turned into a 0. So if we multiply the third row by negative 8 and add that to this one will turn into a 0. So let's go ahead and get my top row done, since that isn't going to change this time. And my bottom row is not going to change because I'm happy with that. So I'm going to do negative 8 times 0 plus 0 is going to be a 0 there. Then I'm going to do negative 8 times 0 plus 1. That'll be a 1. Then I'm going to do negative 8 times 1 is negative 8 plus 8 is 0. Then negative 8 times negative 1/2 is 4 plus 3 is 7. Okay, so things are looking better. Now all I have to get rid of is this negative 2. So if I multiply row 2 here by a positive 2, that will make this one 2, added to that will make it a 0, and we should be done there. So let's do that. So I'm going to leave bottom row alone and middle row And my top row is the one that's going to change because I'm going to take 2 times 0 is 0 plus 1, gives me a 1. 2 times 1 is 2 plus negative 2 is 0. 2 times 0 is 0 plus 0 is 0. 2 times 7 is 14 plus negative 11 is going to be 3. So now I'm in reduced echelon form because all I have is a diagonal of 1s and all I have are zeros. Okay? So once I'm done with that, it makes life real easy because it becomes 1x plus 0y plus 0z's equals 3. So those go away, x equals 3. Same thing is true here, but this time y equals 7, and this time z equals negative 1/2, which is the same answer I got in the other one. And so you can see why I don't necessarily like doing it this way. The other way it's a lot easier because you just back substitute, whereas this way you've got to keep going on these matrices 6 more times in order to get everything to disappear and get zeros. So anyway, sometimes it can get a little bit tougher, and so let's do example 4. Okay, so here's the equation, the system of equations, and what I have to the right is written in the augmented matrix, and it says to use the Gauss-Jordan elimination, which is the one we did last time, which changes everything to zeros. Alright, so let's start going here.